Okay, so we are given that a rectangle has side lengths 3n minus 2 and n plus 4. Use an area model to determine the area. I do want to be clear, whenever you guys have a quiz or a test, I'm not going to prompt you like you were prompted on your practice sets. So you need to be able to produce an area model on your own, just like I have said numerous times in class. So the first thing you do is draw an area model and then label your rows and columns with the appropriate measures. I like to use the first one to represent my height and the second one to represent my width. And then we're going to calculate the area of each region. 3 times 1 is 3, n times n is n squared. 3 times 4 is 12, and we have that 1n. Negative 2 times 1 is negative 2, and that 1n. Negative 2 times 4 is negative 8. We need to combine our like terms to state the area. So 3n squared. Negative 2n plus 12n is just 10n. And negative 8. Okay, looking at number 2. Oh my goodness, sorry, I accidentally erased. I'm trying to put that back there. Looking at number 2, we have the same scenario except different measures. We've got 4k plus 2 and 4k plus 2. So technically this is a square. Okay, but we have 4k and a positive 2, 4k and a positive 2. So let's go ahead and determine the area of each region and then the overall figures area. So 4 times 4 is 16, k times k is k squared. 4 times 2 is 8 times k. 2 times 4 is 8 times k, and 2 times 2 is 4. So the total area of this figure is 16k squared plus 16k plus 4. And I got that 16k by combining these two 8k terms. Okay, number 3. Our rectangle has side lengths 4n plus 3 and 4n minus 3. 4 times 4 is 16, n times n is n squared. 4 times negative 3 is negative 12, and n. 3 times 4 is 12, and n, and then 3 times negative 3 is just negative 9. Let's go ahead and combine our like terms and state the area. So we're going to have 16n squared. 12n plus negative 12n becomes 0n, and we have that negative 9. So technically we have 16n squared minus 9. Now this setup here is technically called the difference of squares. And the reason it's called that is because we have a perfect square minus another perfect square. And let's talk more about this over to the right. We have 16n squared, which is the same thing as 4 squared times n squared, and honestly and truly that is 4n squared. And we know that 9 is the same thing as 3 squared. So that difference of squared pattern here that we see is that 4n, that's the base squared minus our other base 3 squared. And if you ever notice this, there's a nice connection with those factors. So I'm just kind of highlighting to point that out, because it can help you save time whenever you're trying to factor quickly and if you don't have to show your work. Okay, so number 4 here, it says given that a rectangle has an area of 3n squared plus 10n minus 8, determine the binomial side lengths through factoring. Here a is 3, b is 10, and c is negative 8. We need factors of a times c that add to b, so we're going to go ahead and run through that factor tree list. And I kind of paused for a minute because I have found my factors of a times c that add to b. So I'm going to have negative 2 plus positive 12, that equals positive 10. And we also know that negative 2n plus 12n would equal 10n. And so we're going to use this fact to rewrite the b term. So first you're going to go over to the left and you're going to copy down your original problem. Your original problem is 3n squared plus 10n minus 8. And remember, we're going to use that fact that 10n is equal to negative 2n plus 12n to rewrite that b term. So that's what we're going to do right now. And from here, we're going to group our first two terms and our last two terms. For the first group, that greatest common factor is n. And that plus -2 n, that's going to be the same. Well, I'm going to pull that n out. It's going to be the same thing as 3n minus 2. For that second group, the greatest common factor is 4. And right here, notice that our groups are now identical. If your groups aren't identical, you need to see if there's something else you can factor out or check your math, because every single scenario with me, it's always going to end up that they're exactly the same. If they're not the same, you've made a mistake. So anyhow, I'm going to go ahead and factor out that group that's in common. And when I factor that common group out, that leaves me with n plus 4. And we are finished. But moving forward, I'm going to expect you to check your work. And so I'm going to go ahead and model that for you today. First, you copy down your answer, and then you're going to just multiply, the two binomials together. You can use an area model, or you can use just distribution. I'm just going to use distribution here. So 3n times n is 3n squared. 3n times positive 4 is positive 12n. Negative 2 times n is negative 2n. Negative 2 times 4 is negative 8. I'm going to pause and point out that what I have written here in purple and red is exactly the same as what we had up here in the second line of work when we had replaced our b term with what it was equal to, that negative 2n plus 12n. Anyhow, let's go ahead and continue checking our work. We have 3n squared plus 10n minus 8, which indeed checks out. That is exactly what we started with. Okay, so that means that our answer is correct up here. This is a good solution. Okay, so let's look at number 5. Number 5 here, we have 16n squared minus 1. Here our a value is 16, our c value is negative 1, and we don't have a b term, so our b value is 0. We want to find factors of a times c that add to b. Okay, so those factors are 4 and negative 4. We know that 4 plus negative 4 equals 0. So likewise, we know that 4n plus negative 4n equals 0n. We're going to use this fact to rewrite our b term. We're going to group our first two terms and our last two terms to pull out the GCF from each group. The greatest common factor in the first group is 4n. The greatest common factor in the second group is just negative 1. When I factor out that negative 1, it's going to flip the signs inside of my group. And I'm doing that because the first term in this group was a positive. And so I'm going to force this one, the other one to be positive. Okay, now our groups are the same. If that does not happen for you, you've made a mistake somewhere. But I'm going to group out that factor out that common group. And when I pull that common group out, I'm left with 4n plus negative 1, which is the same thing as 4n minus 1. Okay, so this is my answer, but again, I am expecting you to now check your work. So we're going to take our solution, and we're going to multiply those binomial factors together. So 4n times 4n is 16n squared. 4n times negative 1 is negative 4n. 1 times 4n is positive 4n, and positive 1 times negative 1 is negative 1. Again, I'm going to pause and just emphasize that that is exactly the same thing we had in the second line. But let's go ahead and combine our like terms just to prove that this does check out. And yes, that is what we started with. That checks out. Okay, and since that checks out, that means that our solution here is good. Okay, one last one. Here we have 4n squared plus 4n plus 1, and we are determining those binomial side lengths. A is 4, B is 4, and C is 1. We want factors of A times C that add to B. Okay, so there those factors are. We know that 2 plus 2 equals 4. So 2n plus 2n equals 4n. We're going to use this fact to rewrite our b term. So we're going to have 4n squared plus 4n plus 1. I just copied down my original problem. Now I'm going to use this fact over here to rewrite our b term. So 4n squared plus 2n plus 2n plus 1. We're going to group our first two terms and our last two terms. We're going to pull out the GCF from each group. For the first group, the greatest common factor is 2n. And for that second group, the greatest common factor is just 1. At this point, if your groups are not the same, you've made a mistake, but our groups are the same. So I'm going to go ahead and factor out that common group. And when I factor out that common group, it leaves me with 2n plus 1. And at this point, some of you on the scavenger hunt day were a little concerned because you had something times itself. How do you simplify it? You know, anything times itself is that thing squared. So we're going to have 2n plus 1 squared. Okay, so that is our answer. And I am expecting you to check your answers moving forward. So I'm going to go ahead and model that for you. So first I'm going to copy down my solution. Then I'm going to expand it to honor that exponent. And I'm going to go ahead and distribute 2n times 2n is 4n squared. 2n times 1 is 2n. 1 times 2n is 2n. And 1 times 1 is 1. Again, I'm going to take a minute to pause and emphasize that that is exactly what we had up here. So let's go ahead and continue on. Combining our like terms, we find that 4n squared plus 4n plus 1 would be the exact same thing we started with up here. So this checks out, which means that our solution right here is good. It is correct.